Fuerte aplauso a Ricard Broel Gabrielson.
Thank you for that introduction. So excited to be here today in Lima to talk to you about artificial intelligence, foundation models, and generative AI. I think everyone here has probably noticed that AI has done a lot of breakthroughs in the last few years, not least with ChatGPT, but also in many other forms. So the purpose of today's talk is to understand what happened, right? What in our research in AI changed that allowed us to make all of these advances. And then the second talk will be about the consequence of this, right? How do we as individuals, but even more so as businesses, take advantage of AI and not just use AI as a personal productivity tool, but to actually use AI to build competitive advantage and unique selling points, right? To build moat. I mean, it's almost a little bit like a comet has hit Earth, right? And it's almost an explosion that's happening right now. That's what I believe. I think it's going to be a lot of extinction happening in the business world. So it's going to be important as well to think about how to use AI to survive, but also how to leverage AI to build additional competitive advantage. So a little bit about myself. I spent the last 10 years at Stanford and MIT, where I do research on artificial intelligence. I also teach a class at MIT called The Future of AI, so please check that out. I also started a few companies. Everybody at Stanford does. But the most relevant one is called Unbox AI, where we build foundation models, not for language, but for behavior and transactions. So our biggest clients are retailers and banks that have a lot of behavioral data on their customers. And we work with some of the biggest retailers and banks in the world. I'm also originally born in Sweden, so the land of ABBA and IKEA. All right, so what was the breakthrough, right? What was it changed in the research community that allowed us to make all of these breakthroughs? Well, a really good way to think about this is to use ourselves as a reference frame, right? We're born at some point as babies. We have very little knowledge about the world. We're basically blank slate babies. But as we grow up and interact with the world, we learn about the world in the process. So one of the key questions in AI is actually, what allows us to learn about the world? What are the key components that allows us to go from blank slate useless babies to actually useful adults? So when we think about this, we can actually consider a few candidates, a few alternatives that might be most impactful in teaching us about the world. So maybe it's our parents, right? They give birth to us, they raise us, so clearly they are important for teaching us about how the world works. We also have our DNA and genetics. They give us a lot of our physical attributes, but also a lot of our personal characteristics. So they're also important in terms of creating who we become and how we understand the world. But maybe it's very, very flexible, right? People can become very different depending on where they grow up, even if they have similar genetics. And also it's more on a generational scale evolution, right? We also have the academic system, the educational system. Clearly we go to school to learn about how the world works from teachers and experts. There's also a candidate that might be very important to teach us about how the world works. Lastly, we might have more of our, let's say, immediate environment and our emotions, right? We all have different goals. We want to be loved, we want to be successful, and we optimize those goals in our environment, and we learn about the environment in the process. We learn about how different things in the environment allows us to achieve our goals. But we can split these things apart. So these parent-child relationships, you're learning from an expert or a teacher-student relationship, that's called supervised learning. Somebody that knows how the world works, put the world in order for us so we can learn from them, right? There's supervision, therefore supervised learning. On the other hand, we have more of these delayed feedback loops where we focus on the goals we want to accomplish and we learn about the environment in the process. So genetics and evolution is one example, and also how we optimize our goals of want to be loved and appreciated. And that's called reinforcement learning. And this is basically two major approaches that we've been using in AI up until a few years ago. This is what AI was, right? But it turns out that none of these are actually responsible for giving you most of the knowledge that you have about the world, right? In fact, you can thank yourself for that because most things you know, you learn by yourself. How's that possible? Well, it's possible if you start understanding and defining meaning by the context it keeps. So let's take the example of a dog. You don't learn what a dog is from your parents telling you or from your emotions guiding you. You learn what a dog is by observing dogs in different contexts, correlating and contrasting dogs with other concepts. So for you, actually, a dog is something that chases frisbees when those are thrown. It's something that has an antagonistic relationship with cats. It's something that's walked by an owner with a leash. These are the relationships that allows you to actually define and understand what a dog is. And what you get by this is a very relational understanding of meaning. And as you correlate and contrast dogs with other concepts, like cats, for example, you in turn learn what cats are. So it's extremely powerful. You can even learn language this way because the word or name dog will be uttered more in context where dogs appear. And imagine, a little child or a baby pointing at a dog and asking its mom, like, hey, what's that? And the mom says, that's a dog. All that the mom is doing is just providing a label to a concept that the child already understands, right? Just the fact that they can generalize that label of dog to all possible dogs shows you that it understands already and has an understanding of the concept of a dog. So, for example here, right, if I say cat and mouse, there's a pretty clear relationship between a mouse and a cat because we define them in relationship with each other. But if I say dog and mouse, probably that relationship is less clear for you because there's a less strong relationship between a dog and a cat, a dog and a mouse in how we observe different contexts in the world. So since all of these different images that you're seeing are generated using generative AI, right, that use this technique to understand how things work, that's how they learn, we can actually try this. So if I tell a generative AI to generate an image of a cat playing with a mouse, we get something that's, makes sense and is very clear to us. But if I tell this same model to generate a dog playing with a mouse, it gets confused, right? It generates a mouse-looking dog playing with a computer mouse. But that's the interesting fact, right? Because when I said cat playing with a mouse, you probably didn't even think about the fact that a mouse could also be a computer mouse, right? Because the context of the cat made it so clear to you. So when the context is not clear, meaning is not clear, right? This is also true for these AI models because they learn in this relational way. So when you think about AI as well and you start applying it, don't just think that the same context of your business is the same context as somebody else's business. Also, really, that's why you need to bring your AI close and really let it understand and train on understanding your context, because it's so important to get the intelligence that you want. All right. So what does this mean? Well, this means that the more relations that you're able to understand, the better understanding you get of any of those concepts. You understanding what love is helps you understand what a dog is, because an owner loves his dog. So why not, train as big of an AI model as possible with as many parameters as possible on as many relations as possible, right? To get the most precise and powerful understanding of any of those concepts, right? Get all the synergies and network effects. And then use this model anywhere where any of these concepts appear. Well, that's exactly what we're doing, and that's exactly what a foundation model is, right? This is what ChatGPT does, and it's also, in essence, what generative AI does. So this is the core breakthrough that we've been realizing. And of course, your brain is also a prime example of a foundation model. All right. So now we had a short answer to what happened, right? What was the insight that allowed us to build such powerful AI? Now we're going to talk a little bit why it's so important, why we actually needed to have this in order to be able to build what we've been building. So first we're just going to clarify that, when we use mathematics, when we understand all the different things that we're doing, and we don't need to have these super big models, that's in the world of order, right? The world of planets and maybe atoms, where things behave according to simple equations, right? We can do that well. But the world where we want, where our intelligence is useful and where we want our artificial intelligence to be useful is the human world, and that's a very, very chaotic world, right? And that's the challenge, to learn and be able to summarize and navigate this world of chaos. So when we look at the real world where we want our AI to be helpful, like self-driving car, they're actually going to be functioning in this chaotic world. And if you don't believe me that the world is chaotic, just take a taxi ride in Lima during rush hour, and you really see that the world is really chaotic, right? And this is the world we want our AI to actually work. So the question is, how can a computer learn from this chaos? So again, we could try a few things. We can try to say that we as human beings, we navigate this world, we understand this world, so why don't we just try to summarize our own knowledge? Let's try to label different concepts and label the whole world so we can then have our computers learn from us, right? So this is what we tried first. And this is, again, supervised learning, where we as experts label the whole world. But of course, it has huge limitations. This scales with the number of labels that we're able to create. So it scales with human experts. And also, can everything actually be labeled? Can love be labeled? Right? Maybe the world is not that categorical. So it turns out that when we actually try to do this, by itself, it doesn't work and it doesn't generalize. Right? For example, we'll always reach a point where we have not had enough labels. So we'll reach a point here that maybe we have labels on dogs and cat, but the world is not that categorical. So we'll see a very cat-looking dog, and the model will be confused. So this turns out that this only works if you have an infinite number of labels, which you cannot accomplish in the real world. Okay, so then we can also try to say that we're going to do the opposite. We're going to give as little information to the computers as possible to learn from, and then we'll see what happens. And we're just going to say, like, yeah, we as human beings, we have emotions, we have desires, we have goals. So let's just only encode those goals to the computers. So then it has to optimize those goals and try to figure out how everything relates to each other in the process. So yeah, of course, this is reinforcement learning. And here I think it's actually so difficult to imagine what it means to be a computer that has no understanding of how the world works, right? That you're a blank slate baby that has no understanding of how the world works at all. So if you, let's say, you're this computer, which is basically a baby, and you're supposed to optimize a goal. Let's say you want to become less hungry because you're hungry. So you're somewhere, you're a baby, or like you're a blank slate, and you want to become less hungry because that's the feeling that you're feeling. So you have no understanding of how the world works. So you just randomly pick something that you're experiencing and try to understand how that relates to your ability to become less hungry. So let's say you just, pick the moon, and then you'll spend several hours, because there's a delayed feedback loop, right? Try to understand how the moon makes you less or more hungry, and then to try to explore how that correlates, and you'll die, unfortunately, way before you make any progress. So it's so hard, right, to understand, there's no prior knowledge. So this is actually what happens, right? Let's say you want to teach a car to drive from a location to your home. But if this car has no prior knowledge about the world, it doesn't even know where to begin, what to focus on, the moon, whatever. Maybe, but even, let's say by sheer luck, it starts focusing on concepts that are actually very relevant. Let's say that the car starts focusing and trying to understand how other human beings affects its ability to drive home. Great, right? But we still cannot afford to hit thousands and thousands of people before we make any progress, right? Before we learn anything. We can't afford to crash 1 million times before we realize, what we're doing. So it's really too expensive. And it sounds ridiculous, but this is actually how difficult it is to train these AI models using reinforcement learning from scratch. Right? Imagine putting a baby at the steering wheel of a car, and then when it reaches home, you give it a candy. Right? Let's say just by sheer luck, it's able to actually drive all the way home, and you give it a candy, and then you say like, great, now do it again. And this is actually how difficult it is to train these models, and it only works in really, really restricted state spaces like chess, right? But the real world, it's so complicated, so many different options and concepts, so it just doesn't work. So what we realize here is that we actually need to have a basic starting point, a basic world model of how things work, and we need to be able to get that by just observing the world. Because we cannot rely on experts because it's too expensive, we don't have enough of them, and it doesn't work. And we cannot rely on actually trying things ourselves because it's too dangerous. So we need to be able to just learn from observing. Again, we do this, and we're able to do this because we can define meaning by the context it keeps. Right? So a quick recap. The world that we want, that we are useful in, and that we want our AI to be useful in, is a chaotic world. And it's a very difficult world to learn from, and we cannot rely on human experts, we cannot rely on reinforcement learning, so we have to rely on this foundation model generative AI way of learning, which is learning from observation in a relational contextual way. Okay, great. We now know what happened. We now know the insight that allowed us to build this powerful AI. So let's now talk a little bit more about what are the consequences of these insights and breakthroughs, and what does it mean, especially for businesses. So when I started my career in AI at Stanford 10 years ago, and this happened in natural language processing, there was one research team, one data set, and one model per different language task. And they would all work in isolation. So you would have one research team, one AI model, one data set on translation. You would have another data set, AI model, and team working on question answering, etc. But researchers started asking themselves, why are we spreading ourselves thin? Why do we work in isolation when it seems like we're all optimizing the same intelligence, which is language understanding, which is useful and the core intelligence behind all of these different tasks? So they started trying to optimize that intelligence directly and building instead of these separate small intelligences and brains to build one single model that understands language in this contextual way, right? To build a foundation model around language and then seeing all of these different small tasks as just downstream tasks of this big model. And of course, ChatGPT is the prime example of this foundation model for language that solves basically almost any task you can think about in natural language is solved by ChatGPT, which just shows you how powerful it is and how smart it gets because intelligence is really centralized and synergetic. So now we're also seeing the same problems or situation when it comes to companies. Right? So and this is a retailer, for example, but when we come to a retailer, they typically also have, in terms of the AI efforts, they have a separate data set, a separate AI model, a separate team working on product search in isolation. And then they might have a separate AI team and data set and model looking at the marketing, right? But clearly, these are all part of the same intelligence that's really understanding your company, your consumers, and your products. So why not train a single model, a foundation model that understands your business, your consumers, your products, and then use this everywhere, get all the synergy effects, all the network effects, pull the data together, and you get unparalleled performance. So this is what we're seeing, and the results are just outstanding. So what's happening? Well, what's happening is a little bit of an extinction. So now at Stanford, those research teams that try to focus on one specific isolated language task, they went extinct. The only research teams that are able to survive were the ones that focus on a real intelligence that was actually justified. For example, a core language intelligence. And I think we're seeing the same when it comes to businesses, that businesses also need to find what their core intelligence is and be able to incorporate their own competitive advantage to actually survive and prosper. So of course, when we see now that models just get bigger and bigger and better, a natural question to ask is, will there be one single AI model that becomes so smart that it just, rules them all? Will OpenAI have monopoly on intelligence? Well, what we're seeing is that this is actually not happening in the foreseeable future. There will be a collection of intelligences and AI brains or foundation models. And I think one way to see this is that we can look at our own brain, which we've developed over millions of years of evolution, but it's actually not a single brain. Our brain consists of multiple brains. And this is also, I think, what we're seeing now in how these AI brains are starting to develop. So we have these basically multiple foundation models in our brain, where they're just the chat GPT-like large language model is just one part of it. And maybe that's the reason and logical part of our brain, which is actually a very, very small part of our brain. And these brains have developed to be fairly independent by focusing on a unique data and a unique skill. That's what justifies this existence of this AI, sub-brain, let's say, or foundation model. Then, of course, these brains will exist, but they interface with each other very closely and they communicate a lot. And this is also what I think the landscape of foundation models will look like. So what kind of AI brains or foundation models will exist? Well, we will have these more human-inspired AGI-like models that are more inspired how our own brain works. But of course, our brains were optimized for an environment that was different from the modern environment that we find ourselves in now, right? So in this new modern economy, we have new type of skills like logistics, where maybe our human intuition sometimes fails us, and there will therefore be an opportunity to develop a new type of foundation model AI brain for that area that makes sense. So we have, we'll have human-like intelligence, but we'll also have more modern new types of AI brains as well. So again, when you try to understand what type of brains that will exist and what will justify an AI brain, it will be a combination of skill and data type. And in terms of tech, that means proprietary data and proprietary algorithms. And a lot of times, businesses will not afford, and it doesn't make sense for them to invest too much in the proprietary algorithms, but they have to have proprietary data for them to actually stay competitive. So data is going to be so important moving forward. Okay, recap. So we now know that meaning is contextual and relational. So foundation models is what we get from this process of learning in a contextual relational way. And these are the brains that we talk about, right? Foundation models are the brains. They are very, very big in general, but there won't be one single foundation model to rule them all. There will be a collection of them. And the AI brains that will survive here and prosper will be the ones that have proprietary algorithms and proprietary data. Okay, so let's talk a little bit more how that will look commercially, or how I think that will look commercially. Right? These are early signs. I believe that while a company will interface with many AI models, every company will rely on one core intelligence through one AI foundation model that will allow it to structure and encode its competitive advantage, right? So this brain will be its existential justification. It will be critical. And again, of course, you will interface with a lot of other types of foundation models, but for you to be competitive, to have a competitive advantage and a unique intelligence, you need to incorporate that into the foundation model that is the closest to your core business, and really build a moat and defensibility and competitive advantage in that model. And again, other companies that will survive and prosper will do the same, and you will be able to interface with these other type of models. So if you're not Google or Amazon, a lot of times it doesn't make sense for you to build a foundation model or brain from the scratch up, right? to build all the algorithms, etc., and do all the training. So there's going to be a lot of shared AI brains. So it's interesting to ask as well is that, how can we understand companies and industries by now looking at what type of intelligence or foundation model that they are leveraging and incorporate their own data and competitive advantage. So again, there will be, every company will have to have a brain, right, an intelligence, and it has to be sufficiently unique for it to actually be competitive. But there won't be, there will be some kind of collaboration where somebody will provide some technology that you can, and intelligence, you can incorporate your own data. So there will be like, some core models out there that you will leverage, incorporate your own data, and then will use. So if you look at how this is starting to look for industries, for example, if you are a publisher, like Wall Street Journal, or if you're a legal firm, then most of your data and your know-how is in text-based data. So then it does make sense for you to incorporate and leverage mostly a large language model to incorporate your own secret sauce and really structure your intelligence. But if you're Walmart, for example, then your core competitive advantage and your business is not in text-based data, it's in billions of transactions of how your customers are acting in your stores and in your channels. You need to be able to fully leverage that data, which is that's your secrets, right? You need to be able to fully leverage that into your AI models. So then you will not rely, at its core on a large language model, but you will rely on a large behavioral model that really understands human behavior and that you can incorporate your own data in to really understand what your customers want, what products they want, and when. And so on, right? If you're a bank, maybe that's a financial time series model that you need to leverage and incorporate most of your own data to stay competitive. And again, I'm really trying to emphasize the difference here between, just using AI as a personal productivity tool, for example, right? Or just using the AI models that anybody can use. You really need, as a company, to start incorporating your own data and bringing AI close to you, because if you're just using what everybody else is using, then you can be replicated very easily. Okay, so when you think about creating your own AI brain, it's very important to start thinking about what data that you might have access to contains your competitive advantage, right? So start tracking that data, and if there is data out there that has your competitive advantage or understands your business, you need to understand who has that data, because that company is either your best partner or your worst enemy. Okay, so at Unbox AI, my company, we build these behavioral foundation models, right? So these are behavior-to-behavior foundation models that generate human actions and wants. So for example, we're big in retail. And again, retailers come to us because they played with ChatGPT, they're impressed with their abilities, but ChatGPT is not revolutionizing retail at its core, because retail at its core is not text-based data online. Retail at its core is transactional consumption, right? It's behavioral data, so they need to get the same level of deep intelligence, but for consumption, and that's what we provide them. We come into a company, and again, we don't spread our efforts, we don't isolate efforts, we bring everything together to build one single model for retail, right? One single model for this business that does everything, to get all the synergy effects and network effects. So we came in here for this company, for example, they sell wallpapers and posters, and we also, we put the AI, the most powerful AI, at the core of its product offering, right? To make a personalized, tailored experience when you shop. So we understand who you are based on your behaviors, so we can get a very, very personalized, tailored experience. And again, it's very important to put the best AI, the Ferrari, right, at the center of your business. Don't just use an LLM and build a separate business or a separate product. Use AI at your core
channels where users actually use. So for example, right, if you're looking for wallpapers and posters, you might search for blue. But if an AI understands that you're a family looking for something for your child's room, we can give you, blue wallpaper that makes sense because they're blue, but they're very tailored to you as a parent. But if the AI model can understand that you're a teenager looking for something for your room and you search for blue, we can give you completely separate results, both that make sense in terms of blue, but one that actually is what the user is looking for because we know who they are. And this, of course, you want to make as intelligent as possible. And by just, incorporating the best possible AI at these points, we're able to increase sales with up to 24% overnight for this retailer. And what's really impressive is that that's actually done with 12x less work. Because instead of telling users, what experience they should have, we let the users decide what they want by acting in our channels. Here, for example, we have two different AI models, one that's not incorporating this company's data and one that is. So here, the AI model tries to understand similar products. So one AI model thinks that geography is the most important concept. So if you're looking at a skyline, here it's from England or Durham, do you guys think that these are Scandinavian customers? Do you think that when they look at a product of skylines, do they care mostly about the geographical region, right? When they explore skylines, do they care mostly about where it's from? Is that the most important thing? Or is it, like the other AI model says, is it the color palette? Do they care more about the colors than they care about the geographical region, right? What defines meaning and similarity for these users? Both make sense, but one misses the mark completely, and one is exactly what these customers want. It turns out that for this retailer, their customer care much, much more about the color palette than they do about the region, which gives a completely different experience for them. For example, there when we deploy this model on recommendations, in the old model, we can see that based on this Clint Eastwood wallpaper with a gun, right? The old model recommends reasonable results. They're all black and white movie motifs, more from romantic movies, right? But the new AI model is actually smart on this business, understand that this user, is probably a young man maybe, looking for something cool for his room. And it understands it's like old school masculine movies, let's say. They're all both kind of reasonable, but they have nothing in common, and one makes a huge difference, right? It really drives sales. Similarly, if we ask human expert at these companies for search engine optimization, etc., to create keywords for products, right? If you look at this image, which has a lot of different motifs, right? It's a purple sunset with swans, right? So human experts put a lot of different keywords to describe this image, but if you let an AI train on the data and put the keywords that actually users associate with this image, you see that the first one is sunset, which is completely missed by the human expert. Again, it's so important to get this data perspective, understand the language that your customers speak. All right, and this brain now, I just give you, some examples of what it can do. It can basically do anything now because it understands your business. It can help you with fraud because if you're acting in a weird way, you might do something fraudulent, right? It can help you to design new products because it understands what your users want. It can help you with store planning. It can really start helping you to run your business. And what it really is doing is that it's allowing your users to run your business for you by acting in your channels. They're indirectly telling you what you want by acting with your products, right? We also did the same thing for the workforce industry. So we're working with a huge customer service company that has 50,000 employees. And we really trained a behavioral model to understand the employees in a deep way. And after we've done that, we use this model to predict if an employee would quit their job next 2 weeks or not. And this AI model was able to really get to know employees so well that was able with a 91% accuracy predict if somebody's going to quit the next 2 weeks or not. Right? And then you can use this intelligence to really help people be more happy, stay longer, and be more productive. Okay, so to summarize, the AI revolution that we're seeing, that's foundation models, right? And generative AI. And we've gotten this by understanding that meaning is very contextual, right? And that's how we're able to learn this meaning by just observing the world. You also need to understand what really drives your business, so you can incorporate, that core intelligence and structure it into these AI models and let them help you build a competitive advantage. And you need to start doing this by structuring this intelligence, by identifying the data that contains it. And you need to do this early, and you need to do it well, because this is really happening very, very quickly right now. And I think we all know when we work for a business or we run a business that our intelligence as a business has always been and will always be one of the most important things that we have. Before this new way of AI, intelligence was typically encapsulated in the people that work for a company and for the processes that we have in place and the culture, right? And this is still true. But now with the new type of AI, it's going to be more and more important to take that intelligence and also incorporate that into the AI models. So you can really scale it and really get the synergy effects, right? You can really leverage billions and billions of data points that one individual or human beings cannot process. So with that, thank you so much.